That's fine. So random forest classification. So it's a forest, so which comprising of multiple tree. For example, you are having a bucket of fruits. So first tree says you can pick a fruit. First tree says it's a banana. Second tree says it's an apple. Third tree says it's a banana. Fourth tree also says it's banana. So based on majority voting, the result is banana. So always machine learning algorithms are not 100% perfect. Based on your data set, it works. So always data set is very essential. So initially we start with a random forest classification. I hope everyone having Python with Visual Code IDE. Yes or no? Please raise your hand. Whether you are having Python with Visual Code IDE, whether your laptop having Python and Visual Code IDE, say yes or no. If yes, please raise your hand at least. Then I understand the same. Yes, fine. Then, so now it's a complete hands-on practice. Initially, it starts. Thank you. Initially, it starts with intro for 15 minutes. After that, we are entering into hands-on session. Okay, fine. Just for intro. Initially intro, then same exercise we can compare with random forest, decision tree, and SVM. Yes, fine. So starts with random forest. I hope I summarized the yesterday session. So step number 1 for import libraries. So always step number 1 for import libraries. So import pandas as PD, import numpy as NP. Yes, fine. So import 2 libraries. First one pandas, second one numpy. Then second stage for download data set from the drive. Okay, already the drive was shared to you. So already everyone have downloaded this data set. So the data set which will be named as bill_authentication.csv. So download the data set using a single markup, the markup which will be named as pd.read_csv. With the help of that markup, you read the CSV file. And the entire CSV file which marked with the handler named as dataset. The entire CSV file which marked with the handler called as dataset. So similar way, dataset.headof, we choose to display first 5 rows. We choose to display first 5 rows. Now, this is a dataset.headof result. So in that bill authentication CSV, which having 5 columns, the first 4 columns, you are consider it as input X. So first 4 column, we are consider it as input X. The last column, that is class, it's for output Y. Okay. Based on the 4 column, you can predict the outputs. So the next step, this data set which comprising of 5 columns. So first column, first 4 columns are inputs, the last column is output column. Yes, fine. Then next step. So please see here, X equal to dataset.iloc, indexed location, colon, comma, 0:4. So the first 4 columns, 0 to 4, not 5, 0 to 4. These columns which taken into X. The last column, that is 4th column, which taken into Y. So first 4 columns is taken into index 4. Okay, first 4 columns, 0 to 3, index 3, n-1. So 0 to n-1. So first 4 column which taken into in X, variable X. The last column, that is 4th column, that is class, which is taken into Y. So step number 3 over. Step number 1 for import packages. Step number 2 for read data from dataset. Step number 3 for X and Y. Then actually train test split off is a method. We choose to split 80% data for training and 20% data for testing. Here, so X train, comma, Y train, which comprising of 80% data, X test and Y test, which comprising of 20% data. Now, if needed, if your data was not in a proper scale, so you can use a standard scaler. Okay, if the data in first column, which is varies from 0 to 100, second column varies from 0 to 1 lakh, Third column varies from 0 to 1. So like that, you can form the data into proper scalar. So you can use standard scalar method, dot fit transform of x train comma x test. So the values are fit into appropriate scale. Now, normal process. So classifier equal to random forest classifier of number of estimators. Please listen carefully. Number of estimators equal to 20. So if number of estimator equal to 20 means it can construct 20 decision tree. Actually, decision tree is a single algorithm. Random forest, it's a forest. So it's comprising of multiple tree. So n estimator equal to 20 means which can construct 20 trees based on the majority voting. It can predict the result. Okay. So classifier equal to random forest classifier of n estimator equal to 20. Random state is not required. Then classifier dot fit. So in that classifier transform, passing x train comma y train. Then at last, I will print confusion matrix. In regression, I will print mean square error, absolute mean square error, root mean square error. Am I right? But in classification, I will print confusion matrix of y test comma y predicted score. I will explain confusion matrix later. Please wait. Then classification report, y test comma y predicted. So it can print the classification report. Then finally, you can print the accuracy score too. Y test comma y predicted accuracy score. So this is what the first and basic example of random forest classification. Only 6 stages. Stage number 1. So stage number 1, import pandas as PD. We will try the same in system. So okay, you can most of them already tried. Anyway, you can practice parallelly. Okay, I hope everyone having system. So you can practice parallelly. You can open your Jupyter IDE. I will also share my screen. Otherwise, if any student interested, you can share your screen. Then I will explain that too. Any screen sharing from student side? So no issues. I think that Zoom was not shared to students. Okay. Then I will share my screen. Sasireka, please share your screen. So I will open a Visual Code IDE. You can parallelly try the same. I will open a Visual Code IDE. You can parallelly try the same. If issues, if required, you can unmute and speak. Otherwise, raise your hand. Otherwise, at least use chat box too. Yeah. It starts from fresh. So I will open a new Jupyter notebook. File new Jupyter notebook. File new Jupyter notebook. Please, everyone starts. You can open your Visual Code IDE and press File new Jupyter notebook. Open a Visual Code IDE and type File new Jupyter notebook. Then type import. Parallel, you can practice import pandas as PD. Import pandas as PD. NumPy as NP. Zoom the screen. Then import pandas as PD, NumPy as NP. Okay. Initially, the step number 1, zoom please. NP. Okay, fine. Now execute the same. Yes, fine. It ticks marks. So initially the pandas as PD and NumPy NP. Yes, fine. Then step number 2. Step number 2. So I will open a new code. Students practice it parallelly. If issues, please use chat box. Next code, please. If any issues for installing pandas and numpy, I hope everyone well known about Python. So pip install pandas, pip install numpy, it's fine. Otherwise, shall I install the package? If issues, install the package, open the terminal. Otherwise, type here. In the first line, you can type exclamatory mark, pip install. If issues, I think everyone very much familiar about Python, so I won't repeat the steps. If required, you can install pip install Python pandas. Execute. So okay, right here already installed, so requirement satisfied. Similar way, pip install numpy. So step number 1 for install the required packages. So pip install pandas and pip install numpy. I hope everyone already have these two packages. Execute this. After installing these two packages, you can import pandas as PD, numpy as NP. The step number 1, exclamatory mark, pip install pandas and pip install numpy. Then step number 2, import pandas as PD, import numpy as NP. So initially you can install two packages. After that, you can install import pandas as PD, numpy as NP. Is it fine? The two packages are imported. Am I right? Shall I go to next step? At least anyone student can use chat box. Otherwise, I hope everyone having mobile. Am I right? Yeah, fine. So step number 2. So I will read the data from dataset. So import pandas as PD, import numpy as NP. Next step, dataset equal to pd.read underscore CSV. pd.read underscore CSV. Then I can specify my file path, single quotes. Inside single quote or double quote, I can specify my file path. d:/. My file name was billauthentication.csv. So import pandas as PD, import numpy as NP. Then dataset equal to pd.read underscore CSV. d:/. bill authentication. Already the dataset was downloaded, so bill authentication.csv. Then execute the same. Execute the first line. Then execute next. Yes. So now I can open a new code to type dataset, which will print the dataset. Dataset.head of, which print first 5 rows. Dataset.head of, which will print the first 5 rows. Yes. Is it clear? So initially import the packages. After that, read the data from dataset. Then dataset.headof, we choose to display the first 5 rows. It's a first stage. If first stage was clear, then the complete experiment was fine. So if issues in the first stage, it's not possible for continue the next. So please try in your laptop. The chat box is visible to you. So if needed, you can type in chat box. Otherwise, I think only it's in projected in the interactive board. So if required, I will share my WhatsApp number too. The WhatsApp number was shared in chat box too. So if required, you can WhatsApp me if the issues or screenshots. If issues persist, you can unmute and speak. Otherwise, share it via WhatsApp. If issues in the first stage, it's not possible for continue the next. So initially for installing 2 packages, pandas as PD, numpy as np, 2 packages were installed. Pip install pandas, pip install numpy, and then import the 2 packages. Then the read from data from dataset. Then now displaying the first 5 rows of the data. Shall I move to next? So now the data set was ready. Now you can split the data set, prepare the data set. So X and Y. So X equal to the first 4 column which mapped with X, the last column which mapped with Y. So X equal to dataset.iloc of colon, comma, 0 colon 4. So the first set of values, except class, all those columns which will be stored in X dot values. So similar way, Y equal to dataset.iloc colon, comma, 4 dot values. So now execute the same. After that, I will print the X value, which will print the first 4 column. So similar way, Y value, which will print the last column. Okay. So X, so it will print the first 4 columns, first 4 column value in array. Similar way, Y, which will print the last column class. So step number 1 for installing packages. After that, import 2 packages, pandas as PD, numpy as np. Then read the data from dataset. Then dataset.headof, we choose to print first 5 rows. Then preparing the data, X equal to the first 4 columns are grouped into X. Then Y equal to the last column is the output Y. Then now I'm using the train test split off method for splitting 80% data for training and 20% data for testing. So from sklan.model selection, model underscore selection, from sklan.model underscore selection, model underscore selection, import train underscore test underscore split off. Yes, enter. So which returns the four variables. So x and x train, comma x test, comma y train, comma y test. Which is equal to train test split of x, comma y, comma test size equal to 0.2, test underscore size equal to 0.2, that is 20% for testing, random underscore state equal to 0. Now it's splitting 80% data for training and 20% for data for testing. Execute the same. Then fine. Now 80% data was taken into training and 20% data for testing. So initially pip install pandas and numpy, then import the two packages, read the data from data sets, then split x and y. So first four columns is taken into x, the last column is taken into y. Then train test split off is a method we choose to split 80% data for training and 20% data for testing. I will wait for 2 seconds. I will wait for 1 minute, 60 seconds. You can complete this. After that, I am entering into next stage. Please try this. Please, please. Please try these steps. Initially, import packages. I will scroll up. So the stage 1 for import packages. I will scroll up my visual code ID. Please wait a second. Initially for import packages. So import pandas as PD, numpy as NP. Then read data from dataset. So pd.read underscore CSV, d:/bill authentication.csv. So the dataset was read. Dataset.head of, we choose to display first 5 rows. Then x equal to dataset.iloc. So first 4 columns. Then y equal to dataset.iloc of 0, colon, comma 4. Then last column. Now xy was preparing data was completed. Next stage I am entering into train test split off. Train test split off is a method we choose to split 80% data for training and 20% data for testing. Now I am entering into my next stage for classification. So in the classification, I am used random forest classification. So from sklan dot, before that, there is a pre-processing is essential. So from sklan dot pre-processing, from sklan dot pre-processing, from sklan dot pre-processing, import standard scalar. From sklan dot pre-processing, import standard scalar. Then using that standard scalar function, I will create an object for the same. So s equal to equal to standard scalar of. Then next line, x train equal to x underscore train equal to the object SC dot fit underscore transform X train, X underscore train. Similar way, I do the same for X test 2. So only because the last variable is a class. So there is no need to standard scale for last variable. So only the input X test as well as X train was converted into standard scalar. Because some of the variables are like 1 lakh or 2000, something like that. Some variables are lies between only 0 to 1. So all columns are into standard form. So we convert it into standard scalar. Now execute the same. So now X train and X test value should be converted into standard scalar. So from sklan dot preprocessing, import standard scalar. The object SC equal to standard scalar of X train equal to SC dot fit transform of X underscore train. X test equal to SC dot fit transform of X underscore test. Now standard scalar was fine. Now all those values which converted into standard scale. Now I'm entering into the random forest classification. So classifier equal to the object classifier equal to I will use random forest classifier. So I will import the package from sklan dot ensemble from sklan dot ensemble import random forest classifier. From sklan dot ensemble import random forest classifier. Classifier equal to random forest classifier of. So I will call that class random forest classifier class. So in that class, I pass number of trees. So in that parameter constructor, you can pass the parameter n underscore estimator, which is equal to 20 trees. So 20. Then random underscore state equal to 0. So now normal standard step. So classifier dot fit X train comma Y train. So the training variable which passed to that classifier, then the model was trained. So the entire random forest classification model was trained based on this method, X train comma Y train. Now I will pass the test value. So classifier dot Y prediction, Y underscore predict equal to Y underscore predict equal to classifier dot Y underscore predict equal to classifier dot predict of X underscore test. Y underscore predict equal to not classifier dot Y underscore predict. Initially Y underscore predict only, not classifier dot Y underscore predict. It's a variable. So Y underscore predict equal to classifier dot predict of Y underscore test. So the test value, sorry, X underscore test. So X underscore test value which will be passed, caps X. Okay. Now everything was ready. Now the model was trained, as well as the X test value which will be passed, then Y predicted value which was found, then execute. Now entire thing was fine. Final result was predicted. So these are the steps for random forest classification. Then we are entering into metrics, the performance measures. So please try this first. Initially, import package, read data from dataset, prepare the data, X and Y, then train test split off for 80% training and 20% for testing. Then standard scalar, we choose to fit the process into standard scale. After that, I will create the random forest classification algorithm. Next. Then after standard scalar, I will create a random forest classifier model and fit the transform with X train and Y train value. And then passing X test value, you can predict the Y predicted value. Wait for 2 more minutes. Please try this. Scroll down for model. This is for random forest model. So random forest classifier. So here X train and Y train value was passed and then classifier.predict of X test, which can predict the Y predicted value. So Y test is the original value, Y predicted is a predicted value. We can compare the both and we can say the model is properly
Yes,
fit
sir.
or not. Yes, please.
Yeah, sorry for interruption, sir.
No issue.
Can you go a little bit slow, sir? They are typing.
Sure, sure,
So please give some time for the,
sure.
then you can continue, sir.
Okay, sure.
So this is request from students. So
Sure, sir.
thank you, sir. Thank you.
Thank you. I can place the entire code in one notebook and place, then it's easy for typing. So please wait. I will click the code and then copy paste the entire code.
Hello, sir.
Yes, sir.
Sir, I will attach rule number 22. He will be synchronized with you.
Okay.
So whenever he is completed, so that you'll be getting right.
Okay, okay, fine.
Once it is completed, you can. Yes.
Yes, fine. This is the entire code. You can try. This is the entire code, which need 3 package installation. One for pip install pandas, another one for pip install numpy, another one for pip install SCI kitlan. The 3 package installation was needed. Pip install pandas, pip install numpy, pip install SCI kitlan. Then the entire code is here. For viewing the result, at the end I have typed from sklan dot metrics import classification report. Yeah. From sklan dot metrics, I can add another one package. Then only you can view the result too. So I can add another one package in line number 7, line number 6. From sklan dot metrics, the entire code is available. You can try and execute. 3 package installation was needed. One was pip install pandas, another one for pip install numpy, another one for pip install SCI kitlan. Then similar way, now I will add the another one package in line number 6 from sklan dot metric. I will add one more package in line number 6 from sklan dot metrics. So in Visual Code terminal itself, you can type pip install pandas, pip install numpy, pip install SCI kitlan, SCI kit -lan. In the bottom, it will be displayed. Okay. Whether you can type it in terminal or otherwise you can type in code. Code in a sense, it need exclamatory mark in the first, forced to install. Once completed, please inform me. Once it's finished, please message me or unmute and speak. Or otherwise use chat box too. Once completed, please update.
Okay, sir, we have completed.
Thank you, thank you. Then I can add another one more package under line number 6 from sklan dot. In the same stage is enough. rf.py, no issue. Okay, you can add another code. Add a code here. Then from sklan dot metrics import confusion matrix. So here I will find the confusion matrix. So C matrix CM equal to C matrix CM equal to confusion matrix of I will pass the y test value and y predicted value. The variable CM equal to confusion matrix of y test comma y predicted value. Then I will print the CM. So in the next print CM. Print of CM. Then execute the same. TRICS matrix. Okay. Yes, I hope you get the result. 155 to 1117.
Yes, sir, we got the result.
Oh, yeah, super. This is for confusion matrix. Initially, I will explain confusion matrix. After that, we are entering into here. I will share my screen. Please wait a second. Please listen here. This was very essential for matrix. After that, I am entering into the topic. Yes, as classification is concerned, for writing journal, please listen carefully. Because you can find your algorithm was ready, the input as well as output was ready. But how to present the output, that was very essential. The output presentation was completely depends on the confusion matrix, accuracy, precision, recall, and F1 score. So the entire performance measure, which depends on these matrices. So please listen carefully. After that, I'm entering into the demo. Please listen carefully. So confusion matrix, accuracy, precision, recall, and F1 score. These are the excellent measure. I will give a small mathematical example, real world example. Then we are entering into the demo. So we take a problem statement. We take a simple problem statement. Let us consider a task to classify whether a person is pregnant or not a pregnant. Yes, fine. So let us consider a task to classify whether a person is pregnant or not pregnant. If the test for pregnancy is positive, then the person is pregnant. On the other hand, if the test for pregnancy is negative, then the person is not pregnant. So this is what the problem statement. This is what a problem statement was taken. Now consider the classification. We can take a data set. So before entering into data set, so a person is, there are 4 stages. The confusion matrix which comprising of, please listen carefully. The confusion matrix which comprising of 4 stages. The first stage which is called as true positive. The second stage which is called as true negative. The third stage which is called as false positive. Fourth stage which is called as false negative. So a person is actually pregnant. A doctor also correctly identify the person is pregnant. Then the statement was true. Doctor also correctly identified. The statement was true. Doctor also correctly identified. So that's called as true positive. Person is pregnant. Machine also correctly classified. Person is pregnant. So that is called as true for positive statement. Then fine. Now next. A person is not a pregnant. Machine also correctly identify the person is not a pregnant. Actually, the person is not pregnant. Machine also correctly classify the person is not pregnant. That's called as true negative. First one for true positive. Second one called true negative. So machine is correct. If person is pregnant, machine correctly identified person is pregnant. That is true positive. A person is not pregnant, machine also correctly identified not pregnant. That's called as true negative. On the other hand, a person having big belly, but machine can wrongly identify a person is pregnant. That's called as false positive. A positive statement, but that is false. The person is having big belly. Then a person is actually pregnant, machine wrongly identify it's not pregnant. That's called as false negative. So there are 4 cases. True positive, true negative, false positive, false negative. I am giving a problem statement. We will select 100 people. Among that 100 people, 40 are pregnant, 60 are not pregnant. Yes, fine. Now machine can perform the statement. So it's true positive and true negative, false positive and false negative. A machine can identify actually 100 people, actually totally 100 people. Among that 40 people are pregnant, 60 people are not pregnant. 40 pregnant people, machine can correctly identify 30 pregnant. Wrongly identify 10. So true positive. Totally 40 pregnant, true positive. Machine can correctly identify only 30. So true positive is 30. Actually 40 pregnant, machine can wrongly identify 10. So false negative is 10. Similarly, 60 people are not pregnant, machine can identify 55 correct. So true negative is 55. Then machine can wrongly identify 5. So false positive is 5. So this is what the confusion matrix. Please see here. In the diagonal shape. Please see here. This diagonal shape. Please see it carefully. In this diagonal shape, the person is not pregnant. System also correctly identify not pregnant. Person is pregnant. System also correctly identify pregnant. So these 2 stages, system works fine. But these 2 stages, system wrongly identified. Please see your result. Please see your confusion matrix. You are also having a confusion matrix. It shows some result. You are also having your confusion matrix. True negative, true positive. You are having 117 or 150 something. So works fine. But false positive, false negative also available. Some data your machine also wrongly identified. That's for confusion matrix. So confusion matrix, we choose to predict the value. True negative, true positive value. From that true negative, it's set for balanced data set. It's not set for unbalanced data set. So you can find this value. So now I'm entering into my demo. It's for true negative and true positive. I will stop my screen. I will share my Visual Code IDE. So you can see your result. The confusion matrix shows. The confusion matrix which shows true positive, true negative, false and false negative value. Yes, fine. So 155 correct, 117 correct, but 1 and 2 are wrong. I will print the confusion matrix in a graphical representation. I will print the confusion matrix in a graphical representation. I will use the package called as Cbond. Import Cbond as SNS. Import Cbond as SNS. Import Cbond as SNS. If needed, you can install pip install Cbond. Okay. SNS. Then SNS dot heat map SNS dot heat map of CM confusion matrix, comma, annotation equal to true. ANNOT equal to true. Execute. Which visualize my result, T caps. Which visualize my result like this. Please see the graph. Please try this. The entire result was visualized like this. Scroll up. Please type this line. All of them. This graph was essential for placing it in my journal paper. So import Seaborn as SNS. SNS dot heat map. The confusion matrix, comma, annotation equal to true. Please try this, please. Import Seaborn as SNS. SNS dot heat map, the confusion matrix variable, comma, annotation equal to true. So which will display the result like this. Which will show the result like this. Please try this. Please try it little fast. Now right click the image. Right click and save the image in a separate folder. This is essential for journal publication. Right click and save the image in a separate folder. If right click not works in Visual Code ID, then take a copy in the right hand side, there is an option for copy and save. You can copy that image and paste it in Paint. Select the image, click the image in the right hand side. There are 3 symbols was shown. You can click copy, click that image, which shows 3 icons in the right hand side. Then you can click the copy icon. Otherwise, we will print and okay. You can use copy or save. You can use save button and save the image in a separate folder. This is required for your journal publication. So create a folder named as journal, and inside that you can save. What is that result? Confusion matrix or CM. What's the algorithm? Random forest. So CM RF. You can create a new folder named as journal. Inside that you can save the images CM confusion matrix hyphen random forest confusion matrix. CM hyphen RF. So this value which is not fit in a proper scale. So for fit that in a proper scale, I'm using another graph. SNS dot heat map of SNS dot heat map of SNS dot heat map of. I will print the value in a different way. So SNS dot heat map of CM comma, otherwise CM divided by CM divided by numpy NP dot sum of CM. So total values, the particular column value divided by total values. So fine. This is for which represent a matrix, comma, annotation equal to true, comma, annotation equal to true, comma, format equal to FMT equal to FMT equal to single quotes 0.2 percentage, comma, C map equal to, I will represent in different color, C map equal to single quotes blues, B cas. Then execute the same. SNS dot heat map, the heat map which is represent a percentage. Please see here. SNS dot heat map. Then you can find the confusion matrix divided by NP dot sum of confusion matrix. Then now I save the variable in CM comma hyphen RF hyphen percentage. So P. So now I can get the confusion matrix in two different ways for random forest algorithm. Confusion matrix in two different ways for random forest algorithm. I can get confusion matrix in two different ways for random forest algorithm. Please try the same. Once completed, please respond. This is very essential. This confusion matrix was the metric which represented in our journal output. So please try this and respond. Once completed, please inform me. SNS dot heat map of confusion matrix, comma, divided by sum of confusion matrix, then format as well as the C map equal to blue. Blue color is a proper representation in journal paper. So I will represent blue. Please try first. Please do fast. So now we have tried for first algorithm. So confusion matrix is ready. Then I will print precision, recall, and F1 score. Save the image in a separate folder named as journal. Inside that, you can save the image.
Excuse me, sir.
Yes, please.
Sir, one second, please. Can you display the code?
Yes.
Okay, sir. Thank you.
Zoom, please. Zoom. Zoom it. Still more zoom. Enlarge the font size, please. Zoom. Zoom, please. Yes, fine. Import cbond as SNS. SNS dot heat map of CM comma annotation equal to 2. First try this. Next, you can try the next line. I can paste the next line in that line too. Please copy paste the line. So you can try these two lines. Import cbond as SNS. SNS dot heat map of CM comma annotation equal to 2. SNS. Please try first. Only So yes, fine. So C bond. So confusion matrix was completed. After completing this, we will entering into the matrix. Precision, recall, and F1 score. So I will print the value from sklan.matrix. From sklan.matrix. Wait a second, I will share my screen. Again, you can print the matrix from sklan.matrix. From sklan.matrix. Import precision underscore recall underscore curve. Import precision underscore recall underscore curve, comma, AUC. The next line I can type. So precision, comma, recall, comma, threshold. Precision, comma, recall. This curve which return 3 result, precision, recall, comma, threshold, which is equal to precision underscore recall underscore curve of precision underscore recall underscore curve of y test comma y predicted. So which can find based on y predicted and y test, it can find the result as precision recall. The best result as precision and recall result. This is essential for publishing it in journal paper. So precision, yes, fine. So similar way, based on this, I will create the AUC score. So AUC underscore score equal to, it's another metric. So AUC underscore score equal to AUC of recall comma precision. So I will pass the collected result to this method too, recall comma precision. Yes, fine. Now the two methods which works fine. Execute the same. Yes, fine. Now I will plot the graph. So import matplotlib.pyplot as PLT. Import matplotlib.pyplot as PLT. So I can print that same in graphical representation. Matplotlib.pyplot as PLT. The next line I will type. So PLT dot figure. PLT dot figure of FIG size equal to FIG size equal to open parenthesis, close parenthesis, inside that 8,6. So the graph which is little bit larger, then only it's fine for placing it in a journal paper. So 8,6. The next line. PLT dot plot. PLT dot plot. Recall comma precision. PLT dot plot of recall comma precision. PLT dot plot of recall comma precision. Then comma label equal to F. Label equal to F. single quotes. I will print a message. Precision recall curve. Precision recall curve. Precision, and the graph was drawn between precision recall. So precision recall curve for RF, random forest. Random forest. Open parenthesis. Their AUC equal to open parenthesis. Inside that, inside single quotes, open parenthesis. AUC equal to open curly brace. AUC underscore score. AUC underscore score. Small letter. I think the variable in top. AUC underscore score. All small. Colon 0.2F. Execute the same. Then PLT dot show off. Next line. Yes, the graph was displayed. If needed, you can add X label, Y label, X axis getting, etc., etc. Now you can initially try this. Scroll up. Try these lines. Previous. Scroll up. Okay, you can try these 6 lines. From sklan dot metrics, precision recall curve and AUC curve, and find that curve and then plot that curve. Yes, fine. Try this. Try these 6 lines. Fast. Be fast. After that, you can add X label, Y label, and heading 2. Please wait. Try this.
Hello, sir. Hello, sir.
Any errors?
Sir, we have actually from 10:25 to 10:40 we have a break, sir.
Okay, sure.
We'll again join at 10:40.
Okay, sure, sir. Sure.
Okay.
Thank you. So break time. So you can go for break. Join sharply at 10:40. Thank you.
So this here we are going to display AUC underscore score 1 in the format of 0.2F. This is yeah. So now this is plotted. So for that again, as like previous, set the X label, Y label, and title legend. Do it. TLT dot X label. TLT dot X label. X label is recon. Then TLT dot Y label. Y label is precision. And title. Precision. Recon. Not precision 2. plt.legend. Then plt.go. So do it fast. Everything is same like random forest classifier. Do it fast. Already data is prepared. Already packages are imported and data set is open and data is prepared and it is split into training and testing set. So directly we go for the classifier step. So for this tree classifier, we generate a handler classifier 1, then we are making it to fit on our training and training data, then predict. So it first. So after generating the graph, please save the graph in your local drive because for journal creation, for journal preparation, it's needed. Once completed, let me know. So shall we go to next model? Have you created? Once you generated this graph means save the graph in your local drive. This is a precision recall curve for the classifier decision tree. So let me move to next model, SVC. So SVC is support vector classifier. So for support vector classifier, again the same thing. Already data is prepared. So we have a 2 sets, training and test set. So we can directly go for the classifier. So for that we need to import from sklan .svm import SVC. So SVC classifier are imported. Then already we name classifier for random forest as classifier and classifier for precision tree is classifier 1. So here I have taken the variable as classifier 2. Classifier 2 is equal to SVC of. Then we need to make this classifier to fit on a training data. Classifier to fit on a training data. Our training data is in the variable x prime, comma, y prime. Then we need to predict. So for y prediction already for a distant tree classifier, we named it as a y prediction 1. So here I name y prediction 2. Y prediction 2 is equal to classifier 2 dot predict of the input for predict is test x test. Okay. So for SVC classifier is generated now. Then again we need to take the confusion matrix for classifier, SVC classifier. For SVC classifier, again we need to generate the confusion matrix. So here I named it as a CM2. CM2 is equal to confusion matrix of Y test, comma, Y prediction. Then we need to generate the heat map, SNS dot heat map of CM2, then unknown equal to true. Then heat map is generator. Then we need to format the heat map, SNS dot heat map. CM2 divided by NP dot sum of CM2, comma, unknown equal to 2, comma, FMT is equal to 0.2 F, sorry, 0.2 percentage, comma, schema is equal to which. Okay, so for the SVC classifier, we generate the, we create a handler for SVC classifier. Then we make that classifier to fit on our training data. Then we are testing using our testing data. Then the predicted result is used to create a confusion matrix. Then confusion matrix is plotted as a graph. Here, so do it first. The same for the next classifier SVC, support vector classification. Do it first. Okay, completed. So again, calculate precision and recall and AUC. Okay, so precision 2, recall 2, thresholds is equal to precision recall curve of Y test, comma, Y predict 2. Then calculate AUC score. AUC score 2 is equal to AUC of recall 2 precision 2. And TLT dot figure of figure size 8,6. TLT dot plot of recall 2 then precision 2 then equal to precision to, then label equal to. This underscore score to the format of point 2 also. Then for the plot again, set X label, Y label, title, sorry, PLT dot X label. So, remove it. This size is equal to then exit the page. Then select the graph, then save the graph as processing. All go for SPC. Clear, do it fast. Everything is same as like a previous classifier.
Excuse me, ma'am.
Nice.
Please can you show the starting code? I mean, scroll up.
Come again, please.
SVC.
What do you want? Roll up.
Import essays. Yes, ma'am. Wait.
Yes, okay.
Ma'am, completed. Thank you, ma'am.
Okay, okay. Then, so now we get design, implement three classifier, random forest, decision tree, and SPC. For the three classifier, to evaluation purpose, we are using confusion matrix. Then confusion matrix are plotted. Then precision and recall curve also taken for all the classifier. Okay, yeah. Then there are some important metrics. That matrix name is accuracy, sensitivity, then specificity. So accuracy in the sense, the percentage of accurate results including true positive as well as true negative. Already we studied about these four metrics: true positive, true negative, false positive, false negative. Okay. So here the accuracy consider both true positive and true negative. Okay, what's the accuracy of our system is measured in terms of accuracy. And second term is sensitivity. So sensitivity is measured the ability of a test system to test correct result. That is only true positive is measured in terms of sensitivity. Okay. And then third thing is specificity. Specificity is the ability of a system to test correctly determine the cases. Okay, so that is specificity is correctly determined, which is not negative. Okay, so true negative is the ratio between true negative. So the formula for calculating accuracy is the formula for calculating accuracy is then the formula is this is take full accuracy of the system. So both true positive plus true negative divided by all the cases, all the total cases. So total cases in the sense TP plus TN plus FP false positive plus false negative. This is accuracy, the formula to calculate accuracy. And then the formula to calculate sensitivity. So sensitivity is a measure of true positive. Clear? Sensitivity is a measure of only true positive. So true positive divided by total. Total is true positive, true negative, false positive, false negative. True positive, true negative, false positive, plus false negative. And then the next formula for specificity is the measure of true negative. Specificity is a measure of true negative. Is the measure of true negative. So true negative divided by the whole thing, true positive, true negative plus false positive plus false negative. Okay. So what is true positive? This true positive is a number of instances which taken, which give a correct result. Clear? So these all are the measurement. These all are the and again there are so many metrics available. These all are some of the metrics: accuracy, sensitivity, specificity. So we are going to measure this metrics from the confusion matrix. From the confusion matrix, we are going to calculate these metrics. So in confusion matrix, true positive is in the place of, in confusion matrix, the true positive is in the place of index 1, 1. Already we studied about these things. Once again, I repeat. Okay. True positive is 1, 1, and true negative is in the index of 0, 0. Then false positive is in the index of 0, 1. Then false negative is in the index of 1, 0. Okay, clear. Now we are going to calculate accuracy, sensitivity, specificity for all the classifier: random forest, decision tree, and SPC. For the three classifiers, we are going to calculate these metrics. Okay. And first I have taken accuracy 1. This accuracy for for random forest. Okay, accuracy 1 is equal to the random forest confusion metric is CM. Okay, so CM 0,0 plus CM 1,1. Listen, I have taken the sum in the variable total. Okay, total is equal to so total 1 for random forest. I have taken it as a total 1. Total 1 is equal to sum of CM. Okay, for random forest or confusion matrix is CM. So sum of CM. Then I have taken the total in that place. Accuracy 1 for random forest and specificity. Specificity 1 for random forest, which is equal to CM 0, 0, 0, sorry, in formula one change. For specificity, the formula is Tn divided by Tn and Fp. Tn divided by Tn plus Fp. And sensitivity, the formula is Cp divided by Cp plus Fn. Please change this formula. Cp plus Fn. Yeah. So specificity is equal to zero divided by specificity 1, then sensitivity. Yeah. So this is a 3 parameter for the classifier random forest. Okay. Then likewise we can generate this parameter for remaining. For the second classifier, this decision tree classifier, I have taken total 2 and CM1 and accuracy 2, CM1, total 2, CM1, then CM1, specificity 2, sensitivity 2, CM1, CM1. This is for then likewise calculate these three parameters for the next SPC. Taken total 3 CM2 accuracy 3 CM2 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 yeah. So for all the for all three classifiers, calculate accuracy, specificity, sensitivity. So first, so completed. So we go to next step. So in next step, we are going to compare accuracy, sensitivity, specificity of all three classifiers. Okay, yeah. So for that, we are going to pictorially represent the comparison between these three classifiers. So we are going to picturize this answer, these results. Okay. So for publication, this picturization is important. So we need to picturize all the results. So for that, X label. So I'm going to draw a bar chart. And decision tree, random forest, then SPM, supported partnership. Then accuracy, yes, accuracy. So distance to random forest, SPM, accuracy, 1, accuracy, so our classifier is in the order of random forest and decision tree and SPM. So if I take accuracy 3. Then sensitivity, So in x-axis, we are going to take three values for decision tree, random forest, and SVM. So I have set x-axis equal is array of 3. Range. Set the width for the bar as 0.25. Then DLT dot bar. I have taken bar chart, x-axis, accuracy, comma width, comma label is equal to accuracy. And again, I have taken another bar to print to picturize sensitivity. X-axis plus width, comma sensitivity. X-axis plus comma width, comma label is equal to result. So we calculate three parameters for three classifier: accuracy, sensitivity, specificity for the classifier, decision tree, random forest, SVM. So it is plotted. So you can save it.
A very fine good afternoon, students. So, there are two parts of the workshop. The first part for Python implementation. So, we are collecting several results and graphical representation and result. At the end of today's session, I will share the tutorial too. So, during holidays, you can practice the tutorial and collect several graphs for your journal paper. So, the second part, it's for fancy layout creation. So, fancy layout creation with the help of LaTeX. Anyway, you can implement the software in a well-finished manner. Anyway, which need a fancy layout. So, the fancy layout which created via the excellent software which is called as LaTeX. So, the initially we start with small intro on LaTeX. The LaTeX we used for typesetting journal articles, reports, books, and slide presentation. The installation procedure and how to typeset a complex mathematical equation for sensitivity, specificity, precision, recall in a journal paper. Then advanced mathematical notation and LaTeX tips and tricks. So he starts with the small intro on LaTeX. So next day we will implement a complete paper with LaTeX software. Fine. So currently everyone doing research. So which need innovation. So normally scientific community which need a fancy layout for publication quality typeset document. LaTeX is one of the typesetting system for formatting your document to enhance the publication quality. It's a typesetting system for formatting your document to enhance the publication quality. So a picture may worth 1,000 words. Here there is a picture. There is a huge tree. With the help of small saw, if you cut the tree, which will take 10 days. So similar way, you can work for LibreOffice or OpenOffice for creating a journal paper or report writing, which takes more time. But there is an excellent tool, which is called as power cut saw. With the help of that power cut saw, you can cut the tree in a faster manner. If smaller piece of wood, if you are writing a leave letter, in that situation, saw is enough. So normal word is enough. If you are cutting a larger tree, if you are preparing a 70,000 pages book, or if you are preparing your thesis, or if you are preparing a report, or excellent journal paper, in that situation, you can go for an excellent tool, LaTeX. So the LaTeX is produce a publication quality typeset document. It's somewhat easy. It provides an automated typesetting process. It does mathematical notation, does it well. It's useful for academician, researcher for their excellent typesetting document. So normally vegetable shop, it won't need a fancy layout, but a golden jewelry, which need a fancy layout. Similar way, your golden research work, which need a fancy layout. So you can choose excellent LaTeX software for properly formatting your research documentation. You can pronounce it as LaTeX or LaTeX, both are same. It's a typesetting program. Please listen carefully. It's not a word processor. What you see is what you get. It's a typesetting program. You can type a program and you can create a fancy layout. Then it's useful for design beautiful books, theses, papers, and articles. This LaTeX is used for producing beautiful books, theses, papers, and research articles. So it provides a original de facto standard for writing academic papers. It provides the original de facto standard, the original standard for writing academic papers. So let's do LaTeX. For shorter letter, you can use a normal software WYSIWYG editor, but a larger PhD thesis or a project work or paper, you can go for LaTeX. Now, LaTeX is the original standard. It's good for larger document. Even it can run for i386 PC. It's for device independent, so it can run for any system. The LaTeX document which never crash, never lost your file. The LaTeX system which never crash, never lost your file. It can compile even 70,000 pages book. It can compile even 70,000 pages book in a fraction of a second. LaTeX can compile 70,000 pages book in a fraction of a second. LaTeX is not a new tool. It's introduced in the year 1970s by text programming. Don Knuth is a great mathematician. Later in 1980s, it will be Leslie Lamport. They will be modified for text programming into LaTeX. The current version is LaTeX 2E. So user can type a user document. User can type a user document in TextMaker. The user document which merged with .class file, .style file, .bibliography file. User document which merged with class, style, and bibliography, which provided by a college for report, the journal for journal template. So the template which comprises of class, style, bibliography file. So user can create their own user document in text file. These things which combine together, MikTeX is a compiler. MikTeX is a compiler which compile your LaTeX program. MikTeX is a compiler which compile your text program and provide the excellent output in the form of .dvi, .pdf, and .post. Device independent file format, portable document format, as well as PostScript format. So which can provide the excellent LaTeX output, fancy layout. So which need an editor? LaTeX need 3 excellent software for implementing LaTeX. First one for editor, TextMaker. Second one for compiler, MikTeX or TextLive. TextLive which combine MikTeX compiler. In addition to that, all those required package. So initially you can install TextLive software. Then you can install TextMaker software. Then for viewing your result, you can install Acrobat Reader. So these 3 softwares which create a LaTeX. LaTeX which need a compiler, TextLive, editor, TextMaker, viewer for Acrobat Reader. So this is an excellent fancy layout in LaTeX. Excellent fancy layout which created by LaTeX. So learning LaTeX, it's a little bit complex because it's a programming. Than a WYSIWYG editor. What you see is what you get, like a WYSIWYG editor. But LaTeX can produce a 100% quality standard. So than a WAD document, WYSIWYG editors. So it's a first LaTeX program. Please listen carefully. It's a first LaTeX program. So each and every LaTeX document, we start with /document class as article. Each and every import stdio.h like that. Each and every LaTeX document, we start with a markup called as /document class. The name of the class is article. /document class. The name of the class is article. Then /begin document and /end document. Inside that, whatever you can type, it can print in LaTeX document. /document class, you can give any class name, .cls file name, one of the CLS file name which is article. /begin document, end document. Inside that, you can provide the entire content of your journal paper, entire content of your project report, entire content of your book, or entire content of your presentation. Yes, fine. /document class as article, /begin document, /end document. Inside that, you can type your entire content. Then some of the document classes, letter, /document class letter, which create a letter. /document class article, which create a journal paper. /document class report, which create a report. Document class book, which create an excellent book. Then /document class Beamer and Prosper, which used to create the presentation in LaTeX 2. So always every LaTeX document which marked with a markup called as /. So this is my first example. /document class as article, /document class as article, /begin document and /end document. Inside that, you can type welcome you all to the LaTeX workshop. /document class as article, /begin document and end document. Inside that, you can type welcome you all to the LaTeX workshop. This is my first example. I will try the same. These are the software requirements. These are the excellent Tanner chip. Then I will try the same in the software. 1 second. Wait a second. I hope everyone install TextMaker and a text live as well as text maker. So in the day 2 session, we are seeing the basis of Python as well as the random forest, SVM, and decision tree implementation. Okay, small intro on LaTeX. So day 3, I hope everyone install TextLive as well as TextMaker. After that, we create a complete journal paper on day 3. Before that, you are having holidays too. So during that time, you can practice the experiment. So Python implementation is fine. So I will share the URL. So you can practice based on that URL during your free time. After that, we will see the LaTeX on the next day. I hope my screen is visible. So I will open google.com. Please listen carefully. The entire things was available for your support. So during free time, you can practice this. After that, we are entering into LaTeX on later. So in google.com, I will type Kesavaraja, Kesavaraja. Okay. You can open google.com and search Kesavaraja. Then which open my website. You can click on that website, which gives all those tutorials and experiments to you. Open Google and search Kesavaraja, which can provide that website, which can have all those tutorial for Python. So you can open that website. Wait for a second. Then you can click on materials. Click on materials, then machine learning using Python. You can click on machine learning using Python. Machine learning using Python, which can provide the YouTube URL too. You can click that YouTube channel to download whatever, watch whatever machine learning, deep learning algorithm for your project or project works. Then the entire code for regression, linear regression, gradient boost, Bayesian learning, all those algorithms which directly available in Colab, all those data sets are available. In addition to that, all the implementation videos are also available. So you can practice this. After that, the next session on 30th, you can see how to implement a journal paper using your research. Fine. Thank you, students. Thanks for watching. If you have any queries, you can unmute and speak. Otherwise, use chat box too. If you practice these experiments during your holidays, if you have any issues in the website itself, mobile number also available. You can WhatsApp. We will support you. Thank you. Thanks for watching. Thank you all.
Thank you, sir.
Thank you.